is the solution for the problem 01 matrix. It's labeled medium, but it's actually really easy once we understand what an analogy. First, let's discuss what the problem is. You're given a matrix, and in that matrix, there are zeros and ones, only zeros and ones. You have to find for each cell how far away is it from the nearest zero. So, in the case of zero, it's zero distance away from zero. It's trivial case. In case of 1 surrounded by zeros, it's a distance of 1 from any of the zeros. The goal is to find the minimum distance from any element you want to consider to a particular zero. Okay, let's take a look at some of the examples and I'll give you the analogy here. Think about zeros as water and ones as houses. The current one you're looking at is your house and all of your neighboring cells are your neighboring houses. Now, in case of zero, in case of water body, a water body is zero distance away from another water body, which is itself. So the answer is zero. In case of one, it's surrounded by water body, so the answer is the distance to any water body, which is one. Here lies the two observations. Zero is zero distance away from zero, trivial. Second is if a one has zero in its any of its neighbors. So in a case like this where it is surrounded by three ones but one zero, the answer is still going to be one because we are considering the minimum of all these distances. Cool. So let's take a look at more complicated example like this one. In this case, zeros are obviously zeros again. One is again zero. This one is also one distance away. So 1, 1, 1 here. This is again from the first two observations. What about these guys now? In this case, you want to look at all of its neighbors. Now, this neighbor isn't being explored yet, so we can't say anything for sure about this guy. But for both of these, what can we say? See, you are this current house and you want to look at what's happening at the top and to the left, right? If you can get your neighbor's answers, you can just do +1 to it because you're sure that your neighbors have also selected the water body optimally. This is the DP style of thinking. Because one says that, okay, I'm one distance away from this water body, this one can just look at it and say that, okay, since that one is just one distance away, I am two distances away. Make sense? This is sort of the general idea of thinking. If you notice, there's a small flaw here. When we're considering this element, we know the answer for both of these elements, but not this particular element. And that's because the how we have recursed. That's how because we have iterated. So the I goes like this, J goes like this. So this is like the way of exploring it. When you're doing this, when you're going like this, and then this, you haven't explored this yet. You've only explored this one first. You've only explored all of these guys first. What does this mean? This means the case like this becomes harder to solve. Look at this, for example. In this case, this one requires the knowledge of both of these ones, but they haven't been explored yet, and they don't contain the answer. This one again requires the knowledge of what happens in four of these ones as its neighbors. Now, since this doesn't have an answer, this doesn't have an answer, and none of these have an answer, we're stuck in a way. But this is a simple solution. Because we've iterated like this, we can just do the reverse and we can iterate like this again. This will allow you to consider chains going in both directions. Look at this, for example. In normal case, you would iterate like this and will get some particular final answers, and that would be the most optimal case. But to consider both of these cases, as I mentioned this one here, you want to also go to the reverse case. Think about it this way. In the normal case, you're considering what's at the top and what's at the left of the cell. This one, for example, had the answers for this and this. You got the answer for this cell, for example. Now, when you're going the reverse direction, you'll know the answer for both of these instead. It's very simple once you understand it. I'll actually code it up and that should make more sense. So let's look at Okay, let's find n as the length of mat, and then we'll have m as length of mat 0. This is just for convenience sake. And then we'll have an answer, which is another matrix. We're going to initialize things with float of infinity, float of positive infinity, and we'll do this m times here. So that will cover the length of a particular row. And then we'll go column number of times. So for underscore in range of n. This should create the ans matrix. Okay, how do we fill it in? First is the normal direction. We'll consider that. Let's iterate for I in range n, for j in range m. Okay, what now? See, if the cell itself is 0, then the answer is always 0. So if mat of ij is 0, answer of ij is 0. Else, what do you want to consider? You want to look at all of its neighbors and say, whichever is the minimum, give me that, and I'll add 1 to it. But again, you don't consider all of the neighbors, because in the normal case, you only need to consider what's at the top and to the left. Okay, so if I is greater than 0, which means you can do -1, that will make sense in a second. You can try and see if you can get the minimum score of it. So answer of ij, comma, answer of I -1, because you're looking at the topmost cell with the same j, and you'll add 1 to it. And you'll do the exact same for this guy. You'll say if j is greater than 0, which means that if a left element exists, you'll do the same operation here. So in case there is a cell like this which has no top or no left, you don't consider either of these if cases. But it's obviously 0, so the answer is 0. And that we've handled here. Cool. This should take care of the normal case. Now I'll just do a copy paste here for the reversed case. How do we make it reversed? This is how we make it reversed. It's easy peasy. Cool. Again, the same logic follows here. If it's 0, then the answer is still 0. But in this case, now we want to consider if I is less than, I is iterating over n, so n minus 1. Or if I plus 1 is less than n. This makes more sense. And in this case, j plus 1 is less than n. Now I becomes plus 1, j becomes j plus 1. And this should do it. Let's return ans, and we'll do a sanity check here. Cool. We'll run it on sample cases. Okay, fine. We'll just submit it then. And so we have the solution that works. It's 92.24 times faster than everyone else, so it's pretty good. And yeah, that's it. If you found it helpful, put a comment saying that you found it helpful. That gives me feedback. Or if you don't want to do that, just hit a like. Okay, that's it. Bye bye.